Hi, I'm Timber. I'm here with the Cybersecurity Think Tank to talk to you about Network Plus. So let's get started. We're going to be covering the network fundamentals for the CompTIA certification. And we're going to be helping you work towards your IAM certifications. So we're going to start with networking concepts. So we're going to be discussing the Systems Interconnect Models. So we're going to start with the Open Systems Interconnect, the OSI, which is the most popular. You'll hear it till you're blue in the face if you work in this field. The TCP IP Interconnect Model and the DoD Interconnect Model, which you'll only see in specific subsets, depends on where you're working, what kind of work you're doing. If you're a software engineer, or you're going to end up as a software engineer, you may work with the other two models more than the OSI model. These are conceptual models that are created to characterize the standard communication functions of a telecommunications or computing system without regard to the underlying internal structure and technology. So we're going to abstract the discussion to talk about a problem and how it relates to the individual pieces or the layers, and then the teams can go out and figure out which gear is affected by that layer. So for example, one example might be, well, layer 3 problem keeps showing up. We're having some problem at layer 3. We're going to go out and figure out where the troubleshooting is for that. So if somebody tells you that you have a problem on layer 3, or that you need to modify your network structure, and this is all going to be done at layer 3, then the engineers can tell which devices and parts of the network would be impacted by that. And we'll get to that. So that's addressing the last bullet, that this will aid in troubleshooting and engineering discussions. So the 7 layers of the Open System Interconnect Model. Again, this is the most popular model. There's 7 layers, and this is called the OSI model. So they are application, presentation, session, transport, network, data link, and physical. So the application layer, there's also one above this, layer 8, that some people call the human factor, but we're only going to be addressing, and for the test and for real life, people are going to address the 7 layers of the OSI model, and these are they. So you need to know these backwards and forwards. So learn them one direction and then work on learning them in the other direction. You need to know them backwards and forwards. So the way data traverses this stack, and we're going to talk about this till we're blue in the face here, but it starts at the top and it works its way down and it gets transmitted somewhere across a wire, and then it works its way back up. So it goes 7, 6, 5, 4, 3, 2, 1 across a wire. Could be across an ocean, a microwave radio spanning an air gap. Could be the computer sitting next to you, and then it'll work its way back up. So it could be from a web server, comes down the networking stack, comes over, and then back up to a user. So the request would start with the user, it'll go down, make a request to the web server sends the data back down. So it's constantly traversing this networking layer. You may have some times where data is sent at layer 3. It goes down to 2, down to 1, transmitted to some logging server, and then sucked back up to layer 3 and picked off. So it doesn't always traverse the whole stack. It may just go through a few layers. And you may have some monitoring gear that sits on the wire, but as it picks it off, it traverses another stack. So these are just traditional stacks. And whether you're a software engineer, hardware engineer, or just a networking guy, you're going to hear these stacks talked about quite a bit. So everything. So you have like web stacks for web developing and things like that. Well, this is your networking stack. So let's start with layer 7. The application layer is just what it sounds like. It's applications, Chrome, Firefox, Safari, things like that, i.e. they're web browsers that will transmit data over a network. It could also be something like QuickBooks and how it traverses the networking stack, because just about every piece of software today will talk over the wire in some fashion. So layer 7 is responsible for identifying and establishing the availability of desired communication, peer, and verification of sufficient resources for communication. So some examples are, like we talked about, HTTP, secure HTTP, which is HTTPS, right? We don't say SSL anymore because that's defunct and obsolete. It's insecure now. And we don't want to say TLS, because then we label it again as TLS when really it's HTTP and HTTPS, right? Secure HTTP. So then we have SMTP, FTP, SSH, anything that talks over the wire. Could be ping, but ping will occur at a lower level, but it still comes from an application, right? so it still traverses the stack. So the Hypertext Transfer Protocol runs across port 80. HTTPS, or secure HTTP, runs across 443. These are configurable. They're not always stuck to that. You can put them on any port you want, but typically that's what they're at. SMTP is a simple mail transfer protocol that runs on port 25. So SMTP is what you use to send mail, not to read your mail. To read your mail, you're pulling it off of a post office protocol, some kind of POP 110, 995, there's some secure ports. So there's a lot of different ways to read the mail. Many different programs use different ports. But as far as sending mail, it's always going to be done on 25. Mail server to mail server goes over 25. So the FTP transfer protocol, which is port 21, by the way, you need to know all these ports for the test. We're going to cover these later, a complete list. So FTP is 21 and SSH, Secure Shell, is 22. Secure Shell kind of replaced Telnet. It's a more secure version. We still use Telnet, but just for troubleshooting and things like that, diagnosing problems. You can Telnet to port 80 on a web server to kind of pull the page down and look at it briefly, but not through a web browser. So you can kind of look at the raw data coming across. And today we use more advanced programs like a proxy, which we'll talk about later, to kind of analyze, look for problems, things like that. So whether you're a software engineer, a network engineer, or a hardware engineer, you're going to use all this same stuff.